Grade 5 titanium blades. We've all seen it. Jet planes taking off. But how does this actually happen? What's going on inside the engines? Grade 5 titanium blades are providing the initial power to these engines, as well as making sure they remain very stable under high temperatures during operation. Grade 5 titanium blades rotate to provide the air intake to power these engines, as well as to make sure that they remain temperature stable during the operation. Despite the expensive cost of grade 5 titanium, it allows the engine manufacturers and airlines to spend less money on repairs. They're able to invest this money in other facets of their industry.
Originally, prop planes had wooden blades, and then eventually it switched to metals. But it wasn't until turbine engines that planes began to take shape the way that we see them today. The materials of jet engine blades were holding back the true potential of the jet plane. U-500 was first used as a material but couldn't withstand the stress. Then came Inconel and Mnemonic, but it wasn't until a grade 5 titanium alloy that jet engines could have blades that could withstand the stress of flying. Other materials have been considered that also have melting ranges that would be able to withstand the application of engine blades. However, these materials are either not strong enough or are too dense materials to be implemented in aerospace application.
Titanium metal was not implemented outside of a laboratory until after the Kroll process was developed and invented by William J. Kroll in 1940. This process allowed for the full extraction of titanium from crude titanium to pure workable titanium that can be alloyed with. We will discuss this process shortly. Titanium itself was first discovered in 1791 by the Reverend William Gregor, and pure titanium was first produced by Matthew A. Hunter in 1910. This was only when titanium was first identified as a pure element and named in the 1900s, which is not to be confused with when it went into use outside of laboratories. Titanium is the 9th most abundant metal in the Earth's crust, but it does not naturally occur in its pure state. Most titanium is manufactured from ores containing titanium dioxide using a lengthy 4-stage process, which can be simplified into the chlorination of the ore to titanium chloride, the purification of titanium chloride, the reduction of titanium chloride to titanium sponge, and then the processing of the titanium sponge.
Grade 5 titanium is one of the strongest alloys in the world. It is highly corrosion and heat resistant, lighter than most other similar metals, and can withstand high-speed impacts because of its durability. Look at this guy shoot a sheet of this special titanium. Grade 5 titanium is one of the strongest alloys in the world. It is highly corrosion and heat resistant, lighter than most other similar metals, and can withstand high-speed impacts because of its durability. Perhaps the biggest challenge for plane engine manufacturers is mitigating the damage associated with bird collisions. Many planes have crashed due to birds being sucked into the fan blades. One of the main benefits of using grade 5 titanium for these fan blades is the material's inherent durability, which helps to minimize the damage caused by these sudden impacts.
There are several other applications of grade 5 titanium, such as short radius extended reach offshore drill pipes. It is used in this application due to its corrosion resistance and high resistance to plastic deformation. Grade 5 titanium is also used in connecting rods and engines, specifically those of supercars, due to the material's ability to withstand high cyclic loading. Medical implants use grade 5 titanium due to its corrosion resistance and high ductility, allowing it to withstand high stresses that the body endures.